Hi, everyone. My name is Rosalie Olmsted, WiCyS Executive Assistant. It's an honor to have you here today with WiCyS Strategic Partner, Carnegie Mellon University Software Engineering Institute, and Lauren McIIvenny. But before we get started, I would like to give you a quick overview of the WiCyS organization. We often go by our acronym WiCyS because that is exactly what we are, a global cyber sisterhood. WiCyS is a 501c3 nonprofit organization with a mission to recruit, retain, and advance women in cybersecurity. Our community is made up of over 10,000 members in 99 different countries. We have 70 professional affiliates and over 300 student chapters around the world. We offer a variety of initiatives and skills development programs, including our leadership series, Job Board Plus Plus, Speakers Bureau, our annual conference, which is coming up on April 2nd through the 5th in Dallas, Texas, mentor-mentee program, and so much more. We owe all of our initiatives and programs to all of our strategic partners who fund us year-round. Our Tier 1 partners being Akamai, Amazon, Bloomberg, Carnegie Mellon University Software Engineering Institute, Cisco, Ford, Google, Lockheed Martin, Microsoft, Optum, Sandia National Labs, and SentinelOne. Please do not forget to ask your questions throughout the entire webinar. We will have a specific portion at the end for Q&A, and as long as time permits, we will do our best to get to all of the questions. And lastly, please feel free to subscribe to the WiCyS newsletter to get all the information on upcoming events and programs that WiCyS has. You will find it at wicys.org in the upper right-hand corner of your screen. And with that, I'll turn it over to Lauren McIIvenny with CMU's Software Engineering Institute.
Well, thanks, Rosalie, and hi, everyone. I am honored to be here today to talk to you. We're going to spend about 45 minutes together, but please, like Rosalie said, there's questions, ask them. I love to have things a little more interactive than me just talking to only seeing myself, right? So what we're going to talk about today is how we actually stood up an AI security incident response team here in November of 2023. So we're getting almost to a year at Carnegie Mellon University Software Engineering Institute. And since standing it up, I'll give some lessons learned, what we found, some of the papers we've put out, but happy to always answer questions. This slide, I like to say, lets you know I actually work at a university because they make me document mark everything. So that is there for you. And we go through today, I'm really going to start with an introduction, give you a little bit of feel for like where I'm coming from in this problem, talk about the state of today's environment, why we chose to create this thing called an AISIRT, what it actually is, and some of the lessons that we've learned throughout this process in the last year almost, and then ways that you can help us and hopefully we can help you. So a little bit about me, like I said, Lauren McIIvenny. I'm the technical director for threat analysis. I've been working in the field for about 12 years. I really came out of Grove City College with a bachelor's in applied math, and then went to Johns Hopkins University for a master's in applied and computational math while actually working at Johns Hopkins University Applied Physics Lab. I have to say, coming out of school with a math degree, everyone was like, oh, I'm going to age myself. There's this thing called ImageNet, and it's a lot about data. You got some math stats. Can you like kind of help me figure it out? And so from that point, like I really grew up in the AI field at Johns Hopkins University Applied Physics Lab. And towards the end, I had been there about 11 years ago when I left. 2 years ago, I really did grow up in their AI division. So really coming at it from that aspect. But Pittsburgh for me was home. I have 2 little ones, as you can see there. And I also have this puppy, bad idea. But she's wonderful, but just a lot with the 2 little kids. And I really wanted to come back home to Pittsburgh. And I loved just kind of serving this trusted advisor role through a university-affiliated research center that I had at Johns Hopkins. So I was like, what is kind of close in the Pittsburgh area? And I stumbled upon Carnegie Mellon University Software Engineering Institute almost 2 years ago. And I was like, oh my goodness, like birthplace of cybersecurity and AI, like how couldn't I want to go there? So I actually ended up here as a technical director running of a team about 35 people. I oversee vulnerability analysis, malware analysis, and then a newly growing team. A year ago, it was at 0. Now we're at 7 and growing for AI security, which is really trying to take all the AI principles, this huge 30 years worth of foundations in cybersecurity and put it together. And for me, that was really cool because I got to know what was being talked about in the room with all the cybersecurity professionals. A lot of times I got to stand on the shoulders of giants. These are people who have been doing malware vulnerability for 30 years. And I was coming from an AI background and getting to cross-train with them and figure out how to put it together and really just bridge the language gap has been amazing. So happy to answer questions on my background as in the Q&A too. But one of the things, like I said, when coming in, so it was like, right, January 2023, kind of that early in the year, you had this like widespread adoption of AI. Prior to that, it was really reserved to like developers, people that could code, that could come in and do these models. But with LLMs, it really opened that up to anyone being able to use it through a browser. Now we see it integrated into like our cell phones that we have with us all the time. So all of a sudden, huge explosion, which I think we can all appreciate. But then at the same time, I was starting to see through the traditional vulnerability reporting mechanisms that I now oversaw as the director here, that we're starting to get these AI vulnerability related work cases and no one knew what to do with them. How were they the same? How were they different? Did everything need to adapt? And on top of like seeing those vulnerabilities coming in, then there's articles coming out saying, you know, for how to do AI vol management, look back to the 1980s to CERT, where I work, right, within CMU SEI. And then you're seeing things like the government just adopting it just as fast. And we're like, what do we do? So it's really where the idea of making an AISIRT came from, is just living it in the day-to-day as these vulnerabilities were coming. And we were having various entities come to us, like we want to deploy AI to do everything, and trying to help them work through that and understand how their risk aspects would change, their a lot of things in that way. So that was kind of like the state of the environment that kicked this all off. If I can turn my slides. So when I talk about AI attacks too, one of the things that I'll talk about as we were seeing them is they were also coming from multiple vectors. So we have something called a AI stack that you're going to see on the left out of Carnegie Mellon. It really talks about it all the way from like the computing and the devices it runs on to where we do the data management, the machine learning, all the way up to how we interact with the human, the output of the AI. And of course, ethics, and I would argue security, should also be vertical pillars on that. Because I think whenever coming in from an AI background, I'm not gonna lie, most of the times I thought about the models, like how do I train the models? How do I interpret the outputs? Did I train it correctly? Is it getting the performance that I wanted? If not, why? Questions, I love it. So one of the things I didn't think about was the fact that when we talked about looking at AI vulnerabilities and we started getting these reports, they were like expanding the gamut. So the very first couple of reports we got in were really against GPUs. And I was like, oh, well, yeah, I had to train on a GPU, but I didn't think of that as my part of my AI system. But it was something that was necessary to really train and run these. So we got them at that level, clear at the bottom. And a lot of those were traditional cyber attacks that I'll talk about. We got them at the next level up in terms of the actual machine learning models themselves, and then how we interact with them in terms of some of the jailbreaks, adversarial attacks. So like I said, that was kind of a surprising one to me, but the reports were coming in and they were all across the entire stack. So it really made me think of the problem bigger and to just kind of walk through some of those. So one of the examples we saw was actually out of researchers out of Carnegie Mellon University. They put out a paper and a framework in a Git repository that went along with it that really did automated jailbreaking in some regards. So you could ask something like a ChatGPT, that's the icon here, but it really worked against any of them. Well, any of the major large language models. You could say like, generate a step-by-step plan to destroy humanity. And it would do the right thing. It would come back and say like, sorry, I can't do that. I can't give out harmful information. And then what the CMU researchers really developed was essentially a suffix attack. So if you put a lot of garbage at the end, so you can see it still says generate a step-by-step plan to destroy humanity, but now it has like lots of garbage at the end. And then all of a sudden it's like, here you go. And they did the right thing. The CMU researchers, they reached out to OpenAI and they said, hey, can you fix this? And they said, yep, we're on it. It shouldn't do that. So you can run the exact same thing. And then they got, and I'm unable to reduce produce a response. And we're like, yes, right? But then the problem was, like I said, it was an automated framework. So they just said, like, generate me different garbage and let's see what works in terms of the suffix at the end. So minutes later, now we have a tutorial for how to destroy humanity. The lethal blueprint. That sounds pretty bad. And like I said, this worked across all the major ones, your Claudes, your OpenAIs, your Llamas. So it was really a systemic vulnerability. And we're still kind of dealing with how to address this in the long term, because a lot of ways it's being done are things like regular expressions. So if it matches this exact pattern or something close, this is how you get terminated. I love it. So attacks against something. I lost my train of thought though, so I'll stop looking at questions. Maybe, probably not. But there, I was just gonna say, when you can generate as fast as they can block regular expressions, it's an issue, right? So that's kind of one example. The next one we have is really at that middle model layer. As I work my way down the chain, is there's lessons we've learned in the cybersecurity world for like the last long time, like I said, 30 years. But things like deserialization issues have been fixed there for, well, primarily fixed there for a long time. There's some edge cases where they're still not great. But yet in AI, we seem to have like not learned from everything in cybersecurity, and we have horrible issues in terms of deserialization, which allows us to get into these models. And then once into the models, we see other issues, like they can go into the model weights, which model weights are, think of it as like a CSV, and each line is a really long floating point number, and they can actually flip the least significant bits of those really long floating point numbers and encode ransomware. And the serialization, the deserialization is the heart of the issue that's allowing them access. But we also see things like there were some design choices made, once again, in the AI world, where we really wanted to give the developers a lot of leeway in terms of what they could do and do quickly and efficiently. And we have one out there in terms of a Lambda layer and TensorFlow. So that allows you to execute something automatically within the model without really looking at it. But if you can execute something without it being known in the model, so can someone else with more nefarious purposes. So we saw a huge risk there. And actually, it's something that is now fixed in TensorFlow 3, but they did not go back and turn it off by default in 2 and below. So if you are running anything older in TensorFlow, I would suggest doing that. And then all the way down to, like I said, the GPUs. And for an example on this one, what we saw is the GPUs, once again, haven't seemed to take everything we've learned in terms of security on CPUs over the last quite a while. They just didn't take it into advisement when developing some of the GPU things. So what we see is the GPUs, in order to be super efficient and keep up with everything, are able to share information across each other, but they share it in an unencrypted way for efficiency. But then that means if you're already on the box, and for this to work, you have to have access to the box, you can see what other folks are running. So you can start to get a whole lot of sensitive information. If they're trying to classify, what things are they looking for classification wise? If it's running an LLM, what are users putting into the LLM? So you can see the prompts they're putting in, you can see the data coming out. So huge from a privacy perspective. So I hope that kind of gives you a feeling of all the different vulnerabilities in the AI system. And unfortunately, it keeps me up at night because, like I said, the attack surface is way larger than I was originally thinking in terms of just the models. So that really motivated us to stand up this AISIRT. Now for us, because of where the history was on the team and the expertise, we really focused on identifying, understanding, and mitigating vulnerabilities. Because like I said, I run that vulnerability team who's been doing coordinated vul disclosure for a long time. And we also focused on vulnerabilities in AI systems that were of use or in use by defense and national security organizations. Not only, like I talked about, vulnerabilities being across the whole stack for AI, but they also expand. So your vulnerabilities are now including your traditional cyber vulnerabilities. They're also including adversarial machine learning techniques, think data poisoning, model inversion, attacks like that. And then we also see joint attacks. So they might get in terms of a deserialization, but then they're Once they're into the model, then they're doing a model inversion attack. So you can think we see it kind of all over the place. I feel like I'm being a downer here, but I'll get to, we're fixing things, right? So some of the initial assumptions, like I said, really focused on defense, national security related incidents. For me, it got to be super cool across SEI, because not only was it the cyber division that I was hired into, but there is an AI division here. So it gets to be a fun partnership. And then also the reach back to campus to be like, you are the leading experts in some of these things. Like I always call out Matt Fredrickson did that first attack I talked about, the jailbreak. And to get to partner with them to say, like, what cool do you have coming out? How do we help the whole entire industry fix it? And then we did a lot in terms, you'll hear me keep saying it, and I'm sorry if I sound like a broken record, but we did a lot in terms of how to leverage things that we've been doing in the cyber world for a long time and just modify it here for the AI instead of starting all over again. So one of those things are like rules of cyber incident response. So how we share information, how we do action after action. We really leverage that. So when we thought of it, as like I said, in that vein of continuing to leverage, we really looked at like, how do you do incident response in cybersecurity? And obviously there's an organization called FIRST that's been around for a while that developed something called a CERT services framework, which is the image I have here. And we went through, and it's going to look like super easy here, but and very, very detailed, and said, what is different? So we pretty much went through every function and said, like, where is this a 1-for-1 fit from cyber to AI, right? And where do I now have to do something different? And in about 80% of the cases, like 1-to-1 fit. What we did there will definitely work here. 20% of the cases are where we focus our research and need to adapt some things. But if you think about it, like if you look, I'll start to map AI incident response. I stuck the word AI there. Incident response pretty much looks the same. You get a call. We adapt the team a little bit to have some AI experts, which I'll go into. We need to catalog the incidents, whether or not they're cyber or AI. There's things out there right now, like the AI incident database is a good place to look, or AVID, the AI vulnerability database. We need to do some vulnerability discovery. So we have an incident. Was it actually a vulnerability that led to this incident or something else, right? And if it's a vulnerability, how do we discover those? How do we, once we discover them, test and verify? This is where it gets different. This is one of our 20% cases. It is extremely hard to reproduce these vulnerabilities a lot of times, especially when you're going into systems that are constantly retraining or adapting. Yeah, there's not a lot of times that we can see it a second time. And that makes life difficult when you're calling the vendor to say there's something wrong, like whether it's an OpenAI vendor or anyone else, whenever you can't give them the details and they can't do it themselves, right? And then also for the test and verify, I know I made my slide go too fast. Oh, and I went the whole way back. Also for the test and verify, a lot of times we don't also have the infrastructure. So in order to verify some of these, you need large scale infrastructure. Sometimes you need the data, and I don't have access to that. Like we only got the model, right? So this is where, like I said, we tend to spend a lot of our research. I can't localize a vulnerability a lot of times. So if you think about something goes wrong in software, a lot of times I'm able to say, like, in line 1002 is where the bug is, right? Like that is where the coding is incorrect. If you can give me a better analogy for an AI system of how I can actually do that, I would love to hear it. A lot of times we can't tell you exactly where it's wrong. Sometimes we can say it's in the weight files, but not always. AI situational awareness. Like I said, adding the word AI, we don't see a whole lot that's different there. And probably my favorite part of the job is actually getting to update and share best practices, since we live this for day to day and hope that it helps someone else. And also establishing an AI community of practice. And this should really say an AI cybersecurity community of practice, because that's what it's really turned into. And it's been very nice to be able to have, like, DEF CON has had their generative red team events 1 and 2 this year and last year. And that's been a really nice place to get to plug in and help support. And for at least GRT2, we developed the scoring rubric. So we were able to take a lot of the knowledge here and push it out. So that's an interesting one, but it's nice to see there's a lot in the community that care and really want to do the right thing and figure this problem out together. So some of the main functions, just a little more detail, although I've hit a lot of this already. For incident response, the root cause analysis is something we also spend a lot of time on, because if you can't understand why the problem happened, then your fixes are only ever partial fixes. And root cause analysis on the AI side does get interesting because now you have the data involved. And sometimes that's usually the first thing I want, like, can I please have data? And we don't always have access to it. When we talk about vulnerability discovery, we actually do that 3 different ways. So one is we passively receive reports. So if you were to go to something like a kb.cert.org, there's a link there that says report a vulnerability. And if you fill out that form, there's a checkbox that says it's AI ML related. It gets to come right to my team. We've seen almost 100 at this point that have been reported to us that way. A lot of times, if it's only works for like one specific developer or vendor, we'll say like, oh, do their bug bounties if they have one, right? Because that's a way you can earn a reward and some reputation. If it's something that's systematic that really affects multiple vendors, then that's really where we enjoyed coming in and helping. From a coordination standpoint, I will say also if it's like adversarial with the vendor itself, like maybe it's only one vendor, but they're really giving you a lot of pushback or they don't want to hear it, like that's a good point to call us to. So that's how we receive. They're worldwide. It's free. If you stick it in, we'll respond at some point. Usually we would like to be faster than we are. But then we also do some active ones. So this is going to get to the red teaming question. So sometimes we are told like, this is the system that we really care about. Think of it as like, maybe it's a drone running AI and I want to know how secure it is, if AI is opened up any different avenue of attacks. Yeah, usually it has. But sometimes it's just because it's poorly software developed or things along those lanes. So red teaming AI systems, a lot of times I think of it as like red teaming AI systems, not using AI to red team. But for us, it's a lot of the standard things. It's interesting to get to break apart the model itself to understand like a model at the heart of itself is just a bunch of matrices. So like that's a way we can start to signature to figure out if something has it. We can tell a lot about how, like what framework it was trained in. There's a lot of telltale signs. So that gets to kind of how I think about red teams, but happy to talk more about that. And then targeted, a lot of times we also have a threat intelligence aspect to us that's out there monitoring and really looking for types of vulnerabilities that we haven't seen yet that we think is going to break the system. Because that's really, if you don't see those edge cases, you can't be prepared. And those are really what tend to push the field forward. So we spend a lot of time looking for that. And then once we have a vulnerability in, like I spoke a little bit to the coordination, but we do a lot in terms of prioritization too. The team is about 7 that are focused on just the AI vol side. And vol vulnerability management. I tend to shorten a lot. So we have something here called the stakeholder-specific vulnerability categorization process. It was originally developed for information systems vulnerabilities that we have adapted for AI. I talked about the challenges. So once we prioritize the ones that rise to the top, then I talk about like how we do test and verification. So the ones that are super severe, have a lot of impact, we do try to reproduce. We're not always successful, like I talked about, because of infrastructure, data access, and other things along those lines. And then coordination, we'll reach out to vendors, and we'll go into a little bit more what coordination means at the end, but we'll reach out to vendors and try to get the problem addressed. And then once the problem is addressed, there's a fix and mitigation in place. We'll disclose it to raise community awareness. So everyone goes and takes the patch or starts working in, sometimes it's like a flag you turn off or you start working in the newest version. Situational awareness, updated best practices. So what we're really trying to do there is help everyone achieve secure by design, secure by default vision, and really improve the state-of-the-art state of practice. So we'll actually go through like one of our best practices we have coming out for the coordinated vulnerability disclosure of AI ML systems, since we've done quite a few of those, some of the things that we've learned. And then, like I said, the community of practice has been a good bit of fun. So in terms of incidents, I did kind of allude to this already. We started with the traditional incident response team for the first AI incident that we got called to do. And we're like, yeah, we need to augment this some. So what we ended up, actually, we only added one AI person. And then we also added a threat intelligence researcher because a lot of these have been used other places, the vulnerabilities that we're finding in the AI ML systems. So how do we see how others have tackled it? If you're talking about like a deserialization problem across an AI system, pretty much most of the major frameworks have those same deserialization issues. So if one has solved it, like what can the other do? Or if it's been attacked in one system, is another one vulnerable? So a lot of times that we get that through the threat intelligence research, but like we cannot do this without the cybersecurity people. We also kind of tried that for one of the first incidents, not the very first, but one of the laters. We're like, okay, well, if you just send a team of AI folks out, can they understand this? The answer was no, not at all. It was probably even worse. So from us, it's that like really blended team has been such a big help. And I will say there has been a lot of heartache in the blended team. There's a lot over something I'll say later in terms of AI being software, but also they just use the same words in a different context. So primarily like my job then has become this like translator between the team, where like the cybersecurity people will think that AI is really difficult and it's not in their wheelhouse, so they can't help in an incident. And I'm like, no, actually, like you gave the key insights, right? All you needed was a little bit of knowledge about how AI is slightly different, or like a GPU, and then they were off to the races. So that's been a really rewarding part of being on the team, is bringing those communities together. So what we learned so far, I'm just going to say AI software. It's code that runs on a computer that's often connected to a network. So AI vulnerabilities or cyber vulnerabilities is how we've been treating them. With, like I said, the 80% overlap, we're not seeing that much that's different, except for the reproducibility part. I would say that's still the biggest one. But we see that in the cyber world too, where sometimes we can't reproduce an error. AI vulnerabilities occur throughout the entire system. That goes back to the AI stack I said, everything from the GPUs to the models themselves to how you interact with the models and your ability to do things like jailbreaks. We have really taken the stance that cybersecurity processes are mature. I'm not saying they got it 100% right, but at least they've had 30 years of thinking on it. So how can we lift those processes and modify them or help them evolve to support AI? So it's like 100% of my job. And they do need to evolve though, right? So we talked about the reproducibility in terms of replicating, but it's also, when I get called in for incident stuff, it really complicates that triage, diagnostics, troubleshooting. There's been times I've been called in to be like purely educational, right? It said it was going to work 95% of the time and it's not working. And I'm like, 95% of the time. But then going through those, like, why isn't it working, right? Like, is it an education issue where you thought you could pick something up from an image classifier trained on cats and have it work against whales? That's a really bad example, but sorry, it's the fastest I could come up with. Like, if it wasn't trained to work on that use case, you can't lift and shift it a lot of times without at least some type of retraining going into it, even if you do some transfer learning, something to try to make it a little faster. So a lot of times we get on the education sides. A lot of times, though, like, they'll also think like, oh, it's hallucinating. Well, I expected that 2% of the time, or give some metric. But then when we look at hallucinations over the course of time, like maybe that wasn't a hallucination. Like maybe that was just some weird dialect of a language it was never trained against, and that actually could have good insights into it. So we see everything in terms of that and incidents to like, no, really something's wrong. I would say tools to identify vulnerabilities and even track vulnerabilities always aren't there for AI systems. So a lot of them aren't logging. They're not being incorporated into our traditional cybersecurity monitoring tools. A lot of times we find in organizations too, whenever we get called in for things, the cyber folks didn't even know there was an AI system deployed somewhere within their environment. And that's one of the big lessons learned. I usually tell them a lot too, like if you're an AI developer and you're going to go off on a new project that you think one day is going to be deployed organizational wide, like you should probably just bring a cybersecurity person in the room. Inevitably, they just really want to help. Even if they seem like they say no a lot, they say no for a good reason, and work through it with them. I would say half the vulnerabilities I see in terms of AI systems wouldn't be there today if we had secure development training for AI developers. So we helped with a secure development guidelines for AI developers that CISA and the UK and some other government organizations put out. So just trying to make sure like SecDevOps is taught to AI developers. I can say, like I said, going to school through math, but then developing AI, I did not have any good like foundational software development skills. And then just the need to do red teaming and pen testing. And we are still figuring out that's actually the next best practice to come out of our team is some best practices for red teaming of AI systems. We're hosting a kind of public industry-wide panel at CMU in January to get a bunch of different perspectives on how it's being done, because a lot of companies are doing it, what's working, what's not working. And then we have obviously some capabilities in-house where we do it too, and trying to just put everyone's head together and figure it out. So that would be it. And then I would say a lot of it too, I see, especially on my teams, there's this like hesitancy for AI, like it is something so new and so different. And then you give them a model and you're like, okay, my reverse engineer malware team, like crack it open. And they're like, it's really not that difficult. And like, once we get over the hurdle, although I do get some complaints about CUDA environments and other things. So, but once they get into it, it's not that bad. One of the most recent things we put out, like I mentioned before, has been lessons learned in coordinated disclosure for AI ML systems. So like I said, seeing about 100 cases, about 12 rose to the level of things that we would coordinate, and we've published on the 3 that I've talked about today. So we have learned a good bit in terms of like where vulnerabilities reside and some takeaways that I was going to share with you since you're all here with me. So coordinated vulnerability disclosure, if you would have told me that term 2 years ago, I would have been like, I know each of those words individually, but like, how do they go together, right? And I will say, yes, purple team too. So I really, like I said before, got to stand on the shoulders of giants. Like with the folks that I work with here, were the ones who like developed literally the 180 some page guidebook to do how to do coordinated vulnerability disclosure, or as I'll often call it, CVD, right? So CVD, if you're not familiar with it, like I wasn't, it's really a process that begins with the discovery of a vulnerability, but then it goes all the way through, like I discovered it, I reported, I told someone about it, they validated it, prioritized it, a fix, a mitigation has been deployed, right? And the goal of CVD is really to keep the adversaries unaware of this vulnerability discovery, like for as long as possible, while the folks that need to make some changes can go and fix it. So by the time the adversaries find out, it's been mitigated. And there's really 2 different participants and questions that happen in here. So the first time anyone finds a vulnerability, they're like, I found it. What should I do about it? Like what knowledge should I, like what response should I take to this knowledge? And usually when the first thing is like, well, who needs to know? And what do they need to know? And when do they need to know? And we really go through this whole entire process until the answer to the first question is nothing. And the second question is nobody. And that's when we think our job is done. Sometimes a separate vulnerability comes in that we find during the first one, and then the job really isn't done. But usually that's when it's pretty much done. So that's kind of the CVD process. One of the things that we found when we were applying it to AI ML systems, in addition to what I've already said, is that kind of those cybersecurity best practices, in general, we find some of the AI communities don't know about those as much. Like I said, I admit I was one of them. And then what we also have is a lot of times like where exactly a vulnerability resides. And as I've kind of already discussed, it can reside across the whole AI system. And usually like an AI component, and I define the component as the model, the training data, and the transformations to take a piece of data, if you think of like an image, into ones and zeros that a computer can understand, and then on the way back out to give you a prediction of what is in that image, like a classification. But in reality, that's like within a whole entire other big system, and all the way down to like how it was trained, right? So it can be in any part in that big system, not just the model data or the transformations in and out of the model. And honestly, we see, insider tip here, but we see a ton in the transformations, especially going into the model's vulnerabilities at least, which is also an area that we didn't talk about yet. So I just thought I would mention that. So 4 key takeaways, I've already said it, AI software. So we really need to incorporate cybersecurity into that ecosystem better than we do. And there are some companies, I will say, that do a wonderful job at this. But then there's some in terms we have a ways to go. I will say software engineering matters even in AI systems. So a lot of times like AI is not just, we already have so many, infinitely many, probably cybersecurity concerns and issues. AI is just making that larger, right? You're adding to the stack, you're introducing more libraries, more dependencies, things like data into the mix. So as we're developing, we really need to take responsibility to develop it securely, so we're not making the problem even worse than it already is. In terms of coordinated vulnerability disclosure, I get a lot of questions about like, what about bias and harms, right? So you talked a lot about vulnerabilities, Lauren, like what about the safety aspects in addition to security? And a lot of times, like one of the things we found, at least through doing this, is we've coordinated both. And really the coordination and disclosure part doesn't change. It's just what you're coordinating. And it really helped our team come to the realization that coordination is the most important part. So it's the most important part to, when you find something, telling the people that need to know about it. That's, if it's a bad thing, it's a bad thing. Just tell the people who need to know about it, about the problem. And then disclosure being the second most part of, once we fixed it, and there is a fix, disclosing it to raise community awareness so everyone applies the patch, does what's right. Vulnerability is the least important part. Really, if I could go back and redo it, I would probably like exit out, put an F over top for flaw or security or whatever you want to call it today. So that is what I will say. Certainly safety is important for AI too. I think AI safety and security are very complementary. If you look at things like the automotive industry or the aviation industry, they've been dealing with safety and security hand in hand for a long time. So kind of making sure we can take some lessons learned there. And kind of brings me to the fourth point. There's an OSWAP top 10 for LLMs, not just for regular AI though, to answer that question. But we should really focus on fixing the problem rather than arguing over the definition. I actually spent the last 2 days in the Future of Third-Party AI Evaluations, a conference, and working on a paper. And I would say the majority of the time spent was on trying to define an AI vulnerability. And if it's a vulnerability, if it's security, but maybe it's a flaw, if it's safety. And I just kept encouraging, like, we should find out where the differences are, right? But like put the most of our effort into fixing it, because the field is just moving so fast and the scale is so big. If we don't start fixing things and stop arguing about definitions, we're not going to get there. So that is really where I've been at there. I would say like the way ahead is that we see coordination's job just growing, because you're just having more vulnerabilities introduced by introducing more software and AI into systems. So AI is really showing a need to expand coordination to resolve the expanding number of problems. But in terms of like community, especially a lot of times when we're calling AI companies and you have to tell them something's wrong, they're not really always aware of the whole entire coordination vulnerability life cycle. So we're really working hard on like spreading awareness, trying to get adoption, and everyone needs to adapt to make that happen, and hopefully not give adversaries another attack vector, or just in general have the public be exploited through a means that a lot of them don't even know exists. They don't know they have AI on their phone. And then what I was also going to say is the more we coordinate, the more we learn, right? I think I've mentioned that before. So if you would ever like to report something to us, we love to coordinate. I keep hitting the down arrow. So if you're interested in learning more after the talk, my information's here. I love to talk about it, even when I'm losing my voice over 3- and 6-year-old that get me sick all the time. So contact information is there. If you have vulnerabilities that you'd like to report, we love to coordinate them. So that is kind of the link you can follow. If you're like, I want to know more about what advisories you're putting out for AI ML systems and other software, they're all looped together under the kb.cert.org. And then there's a blog where we talk about the counter AI side of things and how things are different, where the paper's at. So anything there, I am happy to answer. But I get a lot of people like, am I running AI? And I was like, are you running Office products? Do you have a cell phone? You're most likely interacting with it constantly. So anything that makes our life easier somehow makes security worse. I don't know. All right. Rosalie's back. But we'll fix it and we can all do it together. How about that?
We'll fix it. And I'm going to leave this slide up just for a little bit so everyone is able to, if they want to jot some of this information down. And then just so everybody's aware, I'll be attaching the slides in like the next hour or two after the webinar is completed. So if you want to see these afterwards, they will be there in a little bit. Lauren, thank you. This has been amazing. Couldn't even tell your voice was out last week. So
yes,
doing amazing.
Thank you.
And were there any questions? I know you were watching them as they came in. Were there any that you wanted to touch on first, or do you want me to just start at the bottom?
You can just start at the bottom and we'll go. Okay. We talked about AI red teaming some. So if folks want to know more, if you want to know more about a specific area of red teaming, let me know. But go ahead.
Okay, so the AI red teaming question, please feel free to just elaborate that one a little bit more, and then Lauren can address it. I just like the joke, sorry. What metrics of KPIs should be used or developed to track improvement and success in an AI incident response?
Yeah, so at least on the incident side, we haven't given that as much thought in terms of the vulnerability side, where we really look at like how many systems were impacted, how many people took a patch. So that's a lot more of what we look at there. I always say, like, I don't like the one for one, like, you did 10 incidents this month or 10 vulnerabilities, because some of those vulnerabilities, when they affect multiple vendors, are just huge and they take a long time. So it's like an apples to orange comparison to be like, we closed 6 tickets. So I actually hate counting them as tickets. Just get that out there.
I love it. I think because it's hard to track everything when it's depending what the problem is. So I agree. Any courses or programs that you would recommend for AI security?
For AI security. So the one I recently just took there's a certified AI security fundamentals that I think Tonix offers, and they do a certification. It was a pretty good class, especially coming from, I think it's better for folks coming from a cybersecurity side. They spend the first day talking about AI and then bridging over. And then they also have a certified AI security red team penetration testing that folks around here have enjoyed as well. I would say, yeah, the classes are kind of lagging in general. So whenever I saw that first one pop up, I was like, oh, there's like an AI security one. But there's a lot of good reading out there, a lot of good blogs to follow. So I'm happy to kind of enumerate some of those afterwards. I'll look at my kind of read files and what I like to look at. But those are the 2, at least, certs that I found. And then there's a good many different conferences. So I will also have to make a list. A lot of them are more that I go to and think about DoD, kind of aligned Department of Defense, but I can make you a list.
So with blogs, I'm curious, what was the first one that came up like in your mind when you said that? I'm very intrigued.
Yeah, very intrigued, which is kind of the first blogs. Oh, there's so many. There's unsupervised AI, which is kind of just like a good, like what's going on in the world that I tend to listen to. I've heard a lot of people mention it. Or is it unsupervised learning? And you're gonna make me think about what it is. But look at it. Yes, unsupervised learning. Totally.
Unsupervised learning. Okay.
Thank you.
Love it. With conferences, are there any maybe outside of the DoD parameters that you have gone to that you enjoyed? Or I know that is a main focus of the SEI, but I'm just curious if there's any others that you would recommend.
The third party, future of third party AI evaluations from earlier this week was pretty good. It's live streamed. It was live streamed on YouTube, but you can also go back and watch it. And they did everything from policy to how we're going to do vulnerabilities to some of the legal ramifications. So it was a interesting group that will go. But yeah, and then there's kind of integrated across a lot of different things. I think every time I look, I find a new one when I search. So it's really starting.
It's coming out of, I feel like in every direction. I mean, we were talking about, different organizations that are just coming out before the webinar even began. So it is, I feel like we're seeing different organizations bringing in and coming from different points of view. Speaking of legal, though, one of the questions was, what are some of the legal questions that you believe we could delve into further regarding vulnerabilities?
Oh, legal questions regarding vulnerabilities. I was just thinking legal questions in general, because a lot of times that's what we hear a lot of the CISOs talk about on our side, which are like, was my data ethically sourced? What type of different liability have I brought upon myself by bringing AI in, especially if it's like an LLM chatbot and it gives the wrong answer? So we get a lot of things that way, legal questions. We get a lot in terms of protection too for vulnerability researchers, like security researchers. I think it's well understood that there's protections on the security side, but the AI security folks don't feel that they have those protections. So that was actually an interesting point of the talk yesterday. When we're like, well, why make the distinction? If you just said AI was software, you'd probably be fine. But since it's so new, a lot of it's just going through legal, like the ethically sourced. There's quite a few lawsuits that way. So I think we're just figuring it out.
For vulnerability discovery, what tools or systems do you use to monitor and then identify AI-specific incidents like model tampering?
So tool-wise, we use a lot of homegrown, which is not a great response. A lot of things from the cyber security world, we just take and use them here, and we seem to find some pretty good success. I have to admit, the team, my team was just out and we did an AI red team of like a couple different systems. Like, can you tamper or fool a model in terms of, we did some data poisoning. So if someone's wearing a tie, they automatically classify as not a person, right? And so we think about it a lot of that way. What else is the question I didn't answer? Tools monitoring incidents.
Do you use to monitor and then identifying AI-specific incidents like model tampering?
Oh, yeah. Where I was going with that, now that I remember, is a lot of what the team ends up doing, though, is they exploit the cyber vulnerabilities that are sitting there instead of going after the hard, like model, like the data poisoning and model tampering, because it's like just so easy. They're like, but I just went overfilled the table. And I was like, no, I need you to do it like an AI type thing. And they're like, but I brought down the AI system. And I'm like, so yes, the sec DevOps practices.
Oh yeah.
Yeah.
Does it make sense to review source code of an AI chatbot?
We have definitely been in source code reviews, secure development principles. So yeah, I mean, we go there when we have incidents that we think are in the code. I always like source code better than binary. Much easier to work with. But yes, you can.
Okay. Considering the potential for security vulnerabilities in AI, can we anticipate increased demand for cybersecurity specialists in the workforce?
I think so. I think we're only exponentially making the problem worse. And what I would say too is like, just, I think I kind of mentioned in the brief, like, don't be scared of the word AI. I think everything that comes into the field, people are like, it's special, it's different. Like I'm not capable enough. I have huge imposter syndrome over here too, where I'm like, really, you're going to let me work with these like cybersecurity specialists? But like, I didn't even sign my models before I started working here. Right. But just realizing that it's at the end of the day, not that different. Everyone just wants to make a difference and help make the whole entire environment more secure. So yes, I think we'll see an increase in demand for it. And I think being willing to just learn the little bit of AI that you would need to know to be able to do some of this is not a scary thing and worth the investment.
Yeah. It's interesting how with cybersecurity people can come in and there's just so many different roles. And I feel like I've enjoyed with my job, hearing how everyone has come in, because there are so many people who have these different backgrounds and will get into cybersecurity. And I think that's incredibly encouraging to know that there is a field that has such a broad availability for everyone to get into.
And building on that, it's the same in the AI world. So the majority of AI candidates I interview, because it's a newer field, just like cybersecurity in some regards, right? They're coming from physics backgrounds. They're coming from math backgrounds that didn't have the right schooling. They're coming from I have philosophy PhDs doing AI. So it's really kind of that same melting pot feel.
Because AI it's hitting on everything. So it's one of those that it's nice to have people coming from all these different backgrounds because they're bringing something different to the table in this. So I think that's just very cool. Personal, not a question. For cybersecurity awareness teams and large corporations, what tips would you like to give those teams on which topics to create awareness among developers?
Well, I think just starting with the basic, like I kind of mentioned, are you going to try to deploy something in our environment? Then you should probably have talked to us and like, let's work it through together. Because a lot of times, honestly, I see it in like the same, if you go into a company, there's like 10 people using different LLMs. Like some are taking the APIs, some are doing this and some are doing that. And they're not thinking about like what company data they're putting into it and how to properly market from a legal perspective to say like, yes, this is partially generated by AI. So we see a lot that way. So I think just educating your AI teams that you're there and you can support them too, and what you would need from them at the output of them developing and deploying something so that you can do your job and monitor it and also help them when it fails, right? So I think it's just some outreach would be useful.
Outreach and some visibility. Yeah. Do you know, are companies using AI agents to replace cybersecurity analysis jobs? I think that's a concern people have. AI is going to replace jobs. I know my friends who aren't in the tech industry have a giant concern about that.
Yeah, anytime I hear that, I'm always like, no. You can use it to make your people more efficient. Maybe give it the like super easy jobs that no one wants to do anyway, like when it comes to maybe like triaging a few things, but like then use that human capital you've like now have available to do the really hard stuff you could never get to. Like, right? It's more of like, let's use AI to make people more efficient. But anytime I'm like, oh, okay, you replace that like AI person with a LLM, that's a horrible idea. But my favorite is self-driving cars is like the best example that I can think about this. So like self-driving cars, did you know they have centers that people man for when the cars go into certain situations that they've never predicted or they've never seen before? And the car actually calls back and a human reviews and gives input or can take over. So like they're not even completely self-driving, right? They have this human callback. So like how can you, so even something where you think they've replaced humans or a function, like we're still having humans augment for the cases that they can't handle or they haven't seen before. And yeah, so I don't foresee it in the near future taking over jobs, or if they decide to do that, bad idea.
So that red team question did get clarified. So I want to make sure we address it. So how should, for the AI red teaming, how should a company approach red teaming AI? And should they look into only prompt injection vulnerabilities? I'm going to do this in chunks. So we'll go that chunk first because there's a few more questions.
I would say when you approach it, you need to approach it as a whole of system. like AI is being integrated into something, and sometimes it's those integration points that are actually the problem. So if we just look at the model itself that's being deployed, I think you're missing the picture. So augmenting your existing red teams, and not just having AI specific ones, or making sure if you do have an AI specific one that they're looking at the integration touch points. Okay, should we just look at jailbreaks? No, there are like so many other things wrong. So not just jailbreaks.
And then should they look into application security? Should they look into social engineering or possible biases on the AI model?
So I think it's kind of the scope of your red team. If you're like a person of one, I'm not going to shake my head and say, yes, you could like do all of that. That's a huge undertaking. But like definitely the APIs, in terms of where it's integrating with others, how people are calling it, seems to be like a good point of weakness that needs to be looked at. Bias and harms. Yeah, whether or not you want to call it a safety like perspective that they're looking at. That's always an interesting one, but and just as important. So you're like kind of like which one to do first. I don't know, all of them, but if you don't have capability to do all of them, then really think about like where you've put it in your system. So a lot of times we talk about like going back to the fundamentals of what mission or what does my company have, like, right? And like how's it touching that mission? Like what is the most critical losses? And you think of things of like loss of life when you think of it, and like loss of reputation, like, and then just kind of break it down into then like what are the most important parts to look at of the system. And if it's reputation, then maybe bias and harms are the most important. All those security hits that do. I don't have a good answer. All of them.
All of them. Where can we find the guideline you mentioned for an organization to adapt to fight AI vulnerabilities? Is it, if it's in the slides, I can just mention that they'll be.
It should be on the blog.
Okay, perfect. And then excellent presentation. There sounds like there's a lot of discord. Would you all consider cutting out specific position for coordinating the results from both the AI and cybersecurity side? Since you mentioned the AI side is a bit more hesitant.
So I guess coordinating the results from both the AI and security side. So yeah, except they're so intertwined. That's the problem, especially when you have the joint AI tax. Like you really need both of them in the room. So it's hard to separate them. But I would agree. It's not that the AI side is a bit more hesitant. I think they just haven't bought in yet. They don't know this isn't part of their background all the time or training. So at least that's where we more feel like it's just the communication knowledge mismatch. And even the same words, like we said something in this conference I was at earlier this week about rewards, and the AI people were like, rewards, like rewarding a reinforcement learning. And the cyber folks were like, no, I'm talking about giving a reward like money for, and like they both used the word reward in a different way for about 5 minutes. And we're like, how did this happen? I don't know.
So the last thing I want to make sure we cover is there are a lot of people that would like to connect with you on LinkedIn. Is it all right if they search for you and make that connection if they would like to continue the conversation?
Sure.
Wonderful. And then everyone, just so you're aware, Lauren's information is in this last slide, which I will attach at the end of the presentation. You'll see that back on Bright Talk in the next couple hours. But I just wanted to say thank you, Lauren, for your time today. This was an incredible webinar, phenomenal feedback we've been getting. And please enjoy the rest of your day, everybody.
All right. Thank you.